just kind of touched upon ratios, rates, and this center. Inside center, we had ratio, rates, and proportion. Then we learned about basic percentage. We just did a recap. Then we looked at the basic uh, data representation, like the bar chart and all that, histogram and line plot, dot plots and all, right? So today we are going to, and we also looked at linear and exponential functions. Okay. So now today we'll do scatter plots, data interpretation and representation, and probability. These three. So if you go to the page number 3 of this one, okay. So this is scatter plot. So next 2 minutes I'm going to be quiet. We both will read the question, right? The first question, this one, right? And then you will tell me. I mean, basically, now we both will have same understanding of the question, and then you'll tell how we're going to solve it and which one is right. Okay. So okay. So let's do it this way. So every sum that we come across, right? What we do is we read that question. So let's read it together. This question says the scatter plot above shows the dimension of 12 picture frames on Lee's wall, along with a line of best fit.
Following statements about the widest picture from frame is true.
Which is the following statement about the widest picture frame is true. Now, first of all, line of best fit. Do you know what is that?
Yeah, that's like is this the straight line that they're showing? That they're the expected based on linear.
This is the x-axis. This is the y-axis. So there are certain points, right, in the xy plane. Let's say, look, so basically the two-dimensional plane, right, we always denote every point as a combination of x and y coordinates, right? So there are 10 points. I'm not going to what is this two-dimensional axis all about. I'm just saying that there are 20, based on the data that we get, there are, let's say, 20 or 25 points in this xy coordinate. So line of best fit is a line which is very close to maximum of the data points. There could be some data points here and here. These are called outliers, right? Line of best fit, it gives you a trend where most of your data is around, right? Okay. So just reading it again, the scatter plot above shows the dimension of 12 picture frames on Lee's wall. Let's say this is the one, okay? Okay, on Lee's wall, along with the line of best fit. So this is line of best fit, which is closer to most of it. Which of the following statement about the widest picture frame is true? Okay. First one is the height of the widest picture frame is 4 inches. Okay. So here, widest picture frame is 4 inches greater than the height predicted by the line of best fit. Okay, so this is the, on x-axis it is the width. This is width, right? On this is height. So it says the height of the widest picture frame, meaning something which is this dimension, where it is the maximum. Widest picture frame is 4 inches greater than the height predicted by the line of best fit. So basically now you have to use the elimination technique, right? Look at this one. In this picture that you see, which is the height of the widest picture frame is 4 inches greater than the height predicted by the line of best fit. Okay. So which is the widest here? Let's say there was a point here, right, which was saying So basically you have to look at these 2 points, right? Which one is the widest? You see, this is the widest, right? This is maximum distance. 4 inches greater than the height predicted by the line of best fit. So this one is 30, 35. First one could be correct, right? That's what it looks like. Let's look at the second one. Height of the widest picture frame is 1 inch greater than the height predicted by the line of best fit. That doesn't seem to be the case, right? This one is 30 and this one is 35. 1 inch doesn't seem to be the case, so we'll just rule it out. Let's go to the next one. The height of the widest picture frame is equal to the height predicted by the line of best fit. No, that is not correct, right? Because this is above this line. So this one is also ruled out. Height of the widest picture frame is 4 inches less than the height of the okay, that got trimmed, but it's saying height of the line of best fit. So height of the widest picture frame is 4 inches less, meaning this has to be somewhere here below. So I think first one is the right answer. So basically, when you look at this question, right, just read it, look at the picture, and then instead of trying to find the best fit, you have to start eliminating the answers actually. Okay? Fine?
Yeah.
Let's look at the second question. Let's read it and then we'll see what seems to be the, are we clear what it is trying to do? A panel is rating different kinds of potato chips. The scatter plot above shows the relationship between their average ratings and the price of the chips. So, y-axis is the rating, x-axis is the price. The line of best fit for the data is also shown. According to the line of best fit, which of the following is closest to the predicted increase in average rating for every 0.1 increase in price? Okay. So you have to look at, you pick any one, right? Let's say 1.5 to 2 and draw a perpendicular line from there. And draw a perpendicular line on the x and y axis. You will see that 0.5 increase in price is leading to rating of 2 almost. I just picked up 2 points. So if you look at this one, right, I drew a perpendicular line from I just picked up 1 point here, right? Let's say if I pick up this point 1, this data point, right, this is at 1 and the next one I pick it at 2. So for $1 increase, how much increase you are seeing? It's going from approximately, right, 1 to 4. So $1 increase is resulting into 3 rating point increase. $1 is 3 rating points. So the question is, correct the line of best fit. Which of the following is closest to the predicted increase in average rating for every $0.1 increase? So 0.1. So this is 10, basically 10 times 0.1 is resulting into 3 point increase. So 0.1 will be 0.3 by 10. So somewhere around 0.3. That's what it looks like. But here we don't have any answer like that, right? So here if you see, right, 1 and 5 can be ruled out. This is just way too much.
Okay.
C and D. Don't go by what I'm saying. Just try double confirming that.
Why would it be 3 over 10 though? Why would it be 3 over 10?
So just pick two data points, right? Let's say I pick this one and this one, right? If I pick this one, this is at 4. This one is at 9. So this 5 rating increase is coming from 2 to 3, meaning $1 increase is giving. See, I just picked up 2 data points here and here. Okay. So this, if you see, this is resulting to $1 increase for rating point increase of 4 to 9. So it's like 5 rating points for $1. So 0.5 rating points for $0.1. So basically simple way to do this is, right, just pick up any of the data points here, okay, any 2, and then see that increase, something which is on the line, a line of best fit, okay. Then pick any 2 data points and see how much is the increase. Again, you have to do approximation. there's no flat mathematics, right? So it's 1.75 to 2.25. So it's 0.5 increase is resulting into 2 rating points. So that is somewhere around 0.5 is resulting to 2. So that is, you have to draw the perpendicular line and look at a couple of scenarios. You'll be able to rule out. See, this 1 and 5 is ruled out because it's just way too much. It is a question between 0.1 and 0.5. 0.1 doesn't seem to be the case because when I looked at $1 increase, it's resulting to 5 data points. If I rating points, if I look at $0.5 increase scenario, if I picked up another combination, I'm seeing a 0.2. So it's something in between 0.4 and 0.5. That's why 0.5 looks more realistic. You can probably pick any other sample also, and see this slope or this line of best fit, right? This is nothing but the linear equation, linear function y equal to ax plus b kind of thing, right? See, this line of fit defines the slope primarily, correct?
Yeah.
So here you'll have to just do some samplings that will help you eliminate the bigger ones and then focus on which looks more relevant. Try doing some samples, when you'll do unit test, you will be able to figure it out. Okay, now let's look at this one. So this one is parabola. Scatter plot can be like in the form of a linear function or quadratic function, okay, or exponential function basically. So here in this case you have to remember only two things, okay. So if you are looking at a scatter plot, okay, meaning data points are like this, or if you are looking at a scatter plot like this, main difference between this and this is a
That's a
exponential.
It's a quadratic. And that's a
Yes,
different.
this is quadratic and this is linear, right? Here, only two things that you have to remember. I mean, only one thing that you have to remember. If the curve of a parabola is upward, okay, this is the coefficient of the x square. So this is like this function, okay, ax square plus bx plus c, okay. This coefficient of x square will be positive if it is upward. If it is downward, it will be negative. So that would be your first clue. So when you look at this one, right? So this is downward. So that is first thing is this is going to be negative.
A, right?
So that gives you the clue. First one and second one is ruled out. Sorry. Third one and fourth one is ruled out because it is positive. So it is between this one and this one. Now, see, let's read the question. Scatter plot above shows y, the number of employees remaining in an office building, x hours after the building air condition stopped working. Of the following question, which best models the data in the scatter plot? Now, look at this one. So now you have only two options to choose from, right? Second thing is ax square plus bx plus c. This c is nothing but the y-intercept always. Okay?
Yeah.
So this c, if you are looking at the equation, any equation, c is the y-intercept, meaning where it touches the y-axis. Here, if you look at this whole parabola, first is it is downward, so you ruled out the positive ones. The equation which has a as a positive coefficient, right? Now we are looking at the y-intercept. Y-intercept is here, somewhere here, right? It is not going to the negative side of y. So it has to be positive. Now between the two, this thing, right? Y equal to minus 7x square plus 8x minus 300 plus 300. Now you know that the y-intercept has to be positive. So the first one is also ruled out. Then you know the answer. So here we don't have to do anything. Just by looking at the question itself or this scatter plot, you can make out that okay, this is a parabola, this is a downward one, no positive thing, and then you looked at the y-intercept. That's it. Going to the next one. Now, so only thing that you have learned so far is that the interpretation of the scatter plot. I believe you might be knowing it already. We just did a revision of that. Now let's look at the next question, which is outside scatter plot. This is on the this is for the chapter probability and relative frequency questions. These are also very interesting questions. Okay, this doesn't require you to do a lot of what you call mathematical calculation. It is based on how do you interpret the data. Okay. Now let's read this question. This is nothing but a table, right? Says it's just a table representing. Okay, let's read the question first. Barento surveyed 151 high school students on their video game related activities. The result are summarized in the table above. If one student from the summary is selected at random, what is the probability that the selected student doesn't play video game and does not watch gaming live stream? You read the question first, then we will try solving it. So somebody did a survey of 151 school students. 151 school students on the gaming stuff, right? Or live stream. So the survey was about people playing video games or watching gaming live streams. Okay, so this is one table. I'm drawing this table so that you will find how easy it is. And again, so this table says plays video games. I'll say play VG. Okay, and then does not play does not play video games. Okay, and this is total. People watching live stream. Watch live stream. Do not watch live stream. Okay, and this is the total. See, the thing why I'm doing this is because when I write this, when I read the question again, when I put it on the notebook, the whole thing becomes much easier to understand. So there are 44 kids who plays video games and watches live stream also. And there are 65 kids who plays video games but does not watch live stream. Okay, so that makes it 109. So if somebody says how many kids play video games, this is 109, out of which 44 watch live stream and this many don't watch live stream. That is the first thing. Now does not play video games. So there are 3 kids who don't watch video games but don't play video games but watch live stream. And there are 39 kids who don't play video games and do not watch live stream also. So this is the finding from the survey done, right? So let's look at the table and things will become much easier. Let's read this data. Okay, this is the way to kill the problem. See, this is the data. I'm not looking at what the question is. Okay, from this data, what is visible is out of 151 kids, there are kids who play video games and there are kids who don't play video games. The kids who play video games, this many watch live stream and this many don't watch live stream. So total number of kids playing video games is 109. And there are kids who do not play video game but watch live stream is 3, and who don't watch live stream also, that is 39. So there are 39 boring kids who neither play video game nor watch live stream. So this is the finding from the survey. So basically somebody took a notebook, asked this question and plotted this data here. Now let's look at the question. We have kind of deliberated this data enough. Now if you read the question, if one student from the survey is selected at random, what is the probability that the selected student does not play video game and does not watch live stream? So we are talking about actually this boring set of students. does not play video game, does not live stream. And this count is 39. So total data that was collected was this. So 39 out of 151 kids have this behavior. That is the answer. That's the probability. Yeah. So basically, these kind of questions, right? They look very cryptic, but when you read it and do a quick sketch, right? You'll find that being the easiest of all the questions. It doesn't require any calculation actually. And now coming back to the probability thing, right? When see this, just doing a recap here, okay? If somebody says, how many kids watch a live stream and play video games? What is the probability of somebody being picked up who play video game and do live stream also? Then this is your column. You will say, okay, there are 44 kids who play video games and also watch live stream out of 151. This is the probability. So based on what question is being asked, kids who watch live stream but do not play video games, that will be this one. Yeah? So, fine. Now let's look at this next question. So, I will not say anything. We both will read this question and you will tell me what to do with this. Or which one is the right answer. Then we'll discuss. What is the answer?
72%.
Yep. I did that to confuse you actually. Because this says what percentage of the gold medal was won by Great Britain and United States. That has to be the first column and the second column, which is 56 plus 23. This is the total number of gold medals won by both the countries, which makes it 79. And total gold medals won by this. So this by this, right? So here you don't have to do that calculation actually. You can use the elimination technique. 28 not possible. This is much more than that. 51 also is not possible. This is more than that. This is a question between 60 and 72. Now 60, this is where by looking at this thing, right? You say that okay, this is more than 70% because 11, 7, 79, 77, right? So this is more than 70%. That's why the answer is D. So here in this case, all your time will go into reading the question and digesting it. And then you will see that there is not much of calculation. You can just go back after approximation and then do it. Okay. So I'm not... Okay. Let's pick one of the questions from data interpretation. Data inference. Okay. Let's read one of the questions. Let's pick the first one. I'm just reading it loud. Okay. A representative sample of household in a city. Okay. Before we go there, a quick thing. Okay. Data inferences. Okay. When you talk about data inferences, what do we know? What do we do? You collect. See. Let's say if you have to get the behavior or the liking of, let's say, for boba in this whole community, in the whole Mikini, nobody would have time and energy to go and talk to each and every individual and note their information and then come out of the finding, right? So what people do is they do sampling, and sampling has to be done in a very unbiased way, so that from that sample, whatever you get information, you can extrapolate that. Let's say you know that the total population of McKinney is this many people, 200,000 people. If you have to get the behavior of this, right? Uh, what percentage of people in McKinney like boba, let's say? You will not go and talk to this many people. What you will do is you will create a very, very diverse sample of, let's say, 100 people, which you will cover different age groups, different ethnicity, different kind of social alignment and those stuff, right? And then make sure that this gives you a view of what would be this interpretation in a larger perspective. So you do the sampling, you collect the data from these many people, and whatever you get, okay, saying okay, out of 100 people, you found that 70 people are liking boba. So you know that okay, 70 out of 100 likes boba. So if I have to extrapolate that, I'll say okay, what percentage, how many people in the whole McKinney might like boba? Will be 70%. So this gives you a likely number. So the only catch here is you have to have a group. You have to decide a sample which is correct, without any bias, without any what do you call anything which can influence this thing. Let's say you say okay, I'll only talk to people from one ethnicity. McKinney is a very diverse place. You have people from different ethnicity, right? If you are only focusing on one ethnicity, whatever data you're getting as a sample, that might not be accurate when it comes to predicting for a larger scheme of things. Okay? That's the only thing that you have to worry about. Now, we are just trying to do some questions. Maybe one question on data inference. Let's read the first question, okay? A representative sample of a household in the city A reveals that 14.8% of the household in the sample have exactly 2 children under the age of 18. If city A has a total of this many household, approximately how many of them have exactly 2 children under the age of? So this is a percentage question actually, right? So I'll probably will not try doing it. I'm just try to confirm that we understood the question right. A representative sample of household in the city reveals that 14.8% of the household, 14.8% of the household have exactly 2 children under the age of 18 years. Okay, that's the first piece of information. If city A has total of 59,317 families, this means household, approximately how many of them have exactly 2 children under the age of 18? So this is a simple percentage thing, right? This is the percentage. So this would have been derived based on some sampling that I was talking about, right? They would have picked up maybe 100 families, 100 households or 200 households, and they derived this percentage. Okay, out of 200 households, probably they would have found that okay, close to 29 or 30 families have 2 kids below 18 years. Now we have to just do the percentage part of it to know the exact count of family or the approximate count of family actually. So when you do sampling and then you extrapolate, you would not claim that it is the exact count. This is the anticipated count. Okay. So this one is simple. We'll not go there actually. Okay. Unless you want to. I mean, I would want you to do the unit test. Huh?
You would just need to find 14.8% of 15,000.
Yeah, correct.
59,000.
Yeah, that's what. See, again, don't go by what I'm saying. If you read the question again, this is what it will mean actually. It simply says that a representative sample of household in city A reveals that this many percentage of household have exactly 2 children below age of 18 years. So they're saying that okay, we did some sampling. I don't know whether it was 5 household or 2,500 household. They did some sampling, and they said okay, this is my likely percentage from the sample. If I have this many families, how many exact household have kids who have 2 kids below age of 18? So it's just about the percentage, right? I mean, that's what the question says. And in case of doubt, right? I mean, when you're solving a problem during exam or no, when you're doing the test also, if you read the question, if you have a smallest of the doubt in mind, read it one more time. Okay. And always use kind of scratchbook for kind of putting something based on what you're interpreting after reading the question actually. Okay. So I'll not do the other ones. Now let's assume that you have understood this or you already knew it. Okay.
Can you go over the second question?
This one?
The Anya, because there's something about a margin error of 3%.
Okay, yeah. This is margin for error. So before we do this sum, right? Let's do a quick recap of what margin of error means actually. So, like I said, when you do sampling, right? You're doing sampling. There's no exact thing, right? Okay. So let's say in this neighborhood, let's say we have 500 families. If you have to find out how many people like Chinese food, we are not going to go and ask everybody. What we'll do is we'll probably collect a sample. We'll collect a sample. Let's say we'll go to 10 families. Okay, we know that we have 500 families. We'll just go to 10 families, 10 diverse families, and then get their opinion about the liking for the food. Okay, so and let's say out of 10 families, we found that okay, 7 of them like Chinese food. Three families either don't like or they don't have any idea about how that food is like. So from this interpretation, you can say 70% of the families mostly like or have a decent opinion about the Chinese food based on sampling, right? Now you will extrapolate that and find out okay, 7 out of 10 is people are liking, so that means 70% of the people like Chinese food in my neighborhood. That is 350. Now this is a guesstimated amount. You think that okay, whatever I have done, probably I might be wrong by 5 to 10%. That is what is called margin for error. That you are saying that okay, I might be wrong by 5%, meaning you derive that okay, from your sample 70% is what it looks like, but I might be wrong by 5%, meaning either I am 75, either the actual is 75% or it is 65%, meaning 5% positive or negative. Okay, so this becomes your range. So even if you're saying that from a sample I got this, if you know what is the margin of error, this gives you, let's say if this 3% margin of error, okay, so you will add 3 positive side, 3 negative side, so that is 6% extra. So your range becomes 70 minus 3 and 70 plus 3. So 67 to 73%. You are giving a range. That's what is called your margin for error. Okay. If your sample is very accurate, very diverse, very much covers all the different possibilities, then your margin for error will be less. If you have made a lot of guesses, you have done a lot of speculation, or you have chosen a wrong sample, that is when your margin of error will be more. Okay. Now let's look at this question. Since if you have understood the concept, this will be a cakewalk. Let's read this. Anya surveyed a random sample of members of a large gym about how often they visit the gym. This is story, right? They surveyed a sample of members of a large gym. So, sample was not large, gym was large. About how often they visit the gym. Using the sample data, she estimated that 74% of the gym members go to the gym at least once a week. So this is what I will do. 74% go once a week. Okay. With a margin of error 3%. So margin of error means this. So if I have to explode this, how I'll write is, this is 74 minus 3, 71%, and 74 plus 3, meaning 77%. This is the range. Okay. Which of the following is the most appropriate conclusion about all the members of the gym based on the given estimate and margin of error? Now, see, when you read the first question, see, margin of error looked very tricky, right? But if we know what it is, and the question itself is very big, we know what it means. Now let's read the answers. Anya is 71 to 77% sure that less than half of the gym members go to the gym at least once a week. See, Anya is 71 to 77% sure that less than half of the gym members go to gym at least once a week. Less than half of the gym members.
That's not right.
That's not correct. Or even if we have doubt, let's park it for now. Okay. Let's go to second one. It is likely that the percentage of gym members who go to gym at least once a week is between 71 and 77%. That is what looks likely. This is what it is, right? That at least 70%, but no more than 74% of the gym members go to the. So C you have to eliminate. This is not correct by any means, right? If we just go by the concept of margin for error, third one can be ruled out. And in the first one, sure that less than half the gym members. This is just a vague assumption here in this question, right? Nowhere it says half of the member and all. It says 74% of the people go to gym once in a week. This statement is nowhere close to what is given in this question actually, right? So A is also ruled out. So B is the likely one. If you read it one more time, it is likely that the percentage of gym members who go to the gym at least once a week is between 71 and 77%. As simple as that, right? So, big question. It looks scary, but if you read once or twice, there is no calculation to be done actually. This is the simplest of the question, right? Now let's pick one more question in the last chapter, which is evaluating statistical claim. So when you look at statistical claim, again this chapter is all about how do you do sampling, how do you ensure that the correctness of data, how do you make sure that whatever sample you are dealing with is that with a bias, without a bias, and how accurate that interpretation or extrapolation could be. Okay, so let's read this question. Okay, forget about any and every concept. There is no new concept that we have learned in this chapter. Okay, pick up the first question, and if that we can do correctly, you don't have to do any further study today. That will complete our unit 3. A youth activist group surveyed a random sample of 500 teenagers between ages of 16 and 17 in the US. So when you look at the question, right, there's a lot of unwanted information that you will have in your question. Okay, so you have to start eliminating that. I'm reading it again. A youth activist group surveyed a random sample of 500 teenagers. So I'll just say 500 teenagers, okay, between the age of 16 and 17. Okay, so the age is 16 to 17. In the US to assess their opinions about lowering the voting age to. Okay, so this whole thing is about surveying this many people in this range to know if the voting age can be brought down to 16. Yeah? Now, the survey showed that the majority of those sampled were in favor of lowering the voting age to 16. Majority of the people, out of 500, majority. I don't know what number it is, but still, it's majority. Based on the results, the majority of which of the following population in the US are most likely in favor of lowering the. Okay. Now look at the question. Let's read the last sentence one more time. Based on the results, the majority of which of the following population in the US are most likely in favor of lowering the voting age? The whole survey was about evaluating these people. All adults, useless response. Eliminate. All registered voters, nobody talked about it, not needed. Eliminate. All 16 and 17-year-olds.
That sounds right.
Okay, that sounds right. Let's look at the fourth option. All students at a particular high school. Nobody talked about a particular school. So this is also a vague option. So the most appropriate answer is C. Did we do any maths? No, we just read English. So any question that you see, right? We'll conclude this class with a punchline that I always tell my students. That when you are dealing with maths, it's a 4-step process. Trust, read, analyze, Nike. Trust meaning before you pick up any question, keep that in your mind that yes, I can do it. Regardless of how big the question is, how cryptic the question is. Just go with the belief that yes, you can do it. This is only a one-time thing. You have to just say, okay, whatever math comes to me, I'll solve it. If anybody can do it, that is me. No preparation needed for this. This is just a belief. Read the question. This is where your maximum energy goes. Read the question once, twice, thrice, till you actually get bored. Till you start thinking that, okay, I have memorized this question itself. So reading that question multiple times and then doing the scratch work. Like I was reading this question, last question, right? I just took the things out. Okay, 500 people were surveyed, 16 to 17 year age. Okay, for lowering the voting age to 16. These were 3 takeaways from the question. I read it 2-3 times to get that thing out. So read the question again and again, at least twice, if not more. Third thing is, now once you have read the question, then you get yourself ready mentally. Okay, this now I understood the question. So okay, this is a percentage problem, or this is what needs me to calculate. The let's say rate of interest. Oh, this is something that is to do with the compound interest or geometry problem, whatever it is. So in your mind, okay, after reading the question, you know what you're going to do and how you're going to do. Make yourself very clear about it. Because if you look at from grade 1 till grade 12, we end up learning, memorizing close to 300 to 400 formulas. Okay? And when we practice them more, we don't have to mug them up actually. Everything kind of gets stored somewhere in the memory. So once you have read the question enough and you have made your mind how you're going to do it, right? Nike says just do it. So when you come to this stage, right, you're already very clear about what you're going to do. You don't have to spend any time for this one. This is a one-time belief that you have to set for yourself. And then your energy goes here and here. Okay? If the script is quite a lot, your energy will go more in this one. Script is less, your energy will go less in that. So that is where you have to kind of practice your reading comprehension, interpretation, doing the scratch work to get the right understanding of the question, and then you start doing it. Apply the same formula. I know this is a little bit of a gyan, but it gets you mentally ready for doing it. Okay? So let's park it now. So with this we have finished unit 3. Essentially you can say unit 2, which is about problem solving in data analysis. And hereafter we'll do foundation of advanced math from the next class onwards.